Okay, this video is going to be just like the last one when we found the ray diagram for the mirrors, and you're going to find things that are going to be very, very similar to what we did last time. We need to define some parts. We already looked at what a focal point was. That's where the light would be focused, but this time it's going to be on the opposite side of the lens because light goes through lenses, whereas for mirrors it bounced off. And then our principal axis is that line through the middle. So here's our focal point. We have two focal points. This lens is called a convex lens, but it's more commonly known as a converging lens. So instead of in the word problems, they're not going to say you have a convex lens. They're going to say you have a converging lens. And it's called a converging lens because see these parallel light rays, they converge at that focal point. And why are there two focal points? Because remember when we had mirrors, we just had one focal point. There are two focal points because the light can come from the other side and focus over here. So there's going to be two focal points for our lenses. So there's three rays we draw. We only have to draw two. The third is optional and is extra credit. It's kind of gravy. They should all come together. Our easiest one goes from the top of the object through the middle of the lens on the other side without. So it just goes zoom straight on through. So you line up the top of the image with the middle of the lens and go zoom. Our second ray goes in parallel to our principal axis, out through the focal point. That ray should look familiar because we did that one when we had mirrors too. In parallel, out through the focal point, and look, they cross right there. We've already found our image. That's going to be the top of our image. It's inverted, so what do you think that means? Our third ray, this is our extra credit ray, goes in through the other focal point. So for a converging lens, this is our primary focal point. So now we're going to go through the other focal point and out parallel. And they should all meet up in the same spot. So straight through the middle, in parallel, out through the focal point, in through the other focal point, out parallel. And where they meet up, that's where you have your image. So how do we describe this image? It's inverted, so that means it's real. Just like with mirrors, if it's inverted, it's real. And if I put a screen right here, that would project the image onto the screen. So we'll do that in class. It's reduced. If you actually measured this and measured this, you would find it was a little bit smaller, but not much. It's not always this easy, because just like with mirrors, other things can happen, but we still draw the same three rays. Zoom straight through the middle, in parallel, out through the focal point. Now see these guys here? They're never ever going to meet up. So we need to bring back the refracted ray, just like in mirrors we brought back the reflected ray, and our image is going to be back here. This is an upright image. It is magnified. See, it's much bigger than... So this is how magnifying glasses work. And it is a virtual image. Okay, remember, it's made out of dotted lines. So it's not really there. It's not going to be projected onto a screen. Basically, what this kind of lens does is it pushes the object away, or the image away from us, so it looks bigger. And what about that extra ray? We're going to go in through the other focal point. So we're going to go in through the other focal point and out parallel. So we're going to line up the image with the other focal point. So that's kind of hard to see. In through the other focal point And see how it didn't really hit the lens? We just draw a line down the middle of the lens and make it bend at that spot there. Out parallel. These three rays again are never going to meet up, so we'll bring it back, and it'll still meet up with the third ones. So these are our three rays. Straight through the middle of the lens, in parallel, out through the focal point, in through the other focal point, and out parallel. Pause the video now and write down these three rays. Okay, so concave lenses. Concave lenses act like convex mirrors. They're very similar to each other. So they're called diverging lenses because when the light rays come in, it actually spreads out those light rays, so they diverge from each other. They go away from each other. But they seem to meet up back here at this focal point. So this is our focal point for a diverging lens or a concave lens. So we still have the same three rays. Zoom straight through the middle. In parallel, out through the focal point. But remember, our primary focal point's back here. So we're going to line this up out through the focal point, and that's going to make that little image right there. Bring that back. So how would we describe this? Upright, reduced. How do we know it's virtual? We know it's virtual a couple ways. One, it's upright. So if it's upright, it's virtual. The other way we know that it's virtual is that it's made out of dotted lines. It's not a real light ray. Okay, so that extra ray, the third ray, this one's kind of tricky like it was for the convex mirrors. You're going to go in through the other focal point. So you're going to go in as if you're going to go through this focal point, but you're going to stop when you get to the middle because that's where it bends. And when it does it, it goes in through the other focal point, out parallel, and you're going to trace back that refracted ray. And so altogether, this is what it looks like. Here's our three rays, straight through the middle, in parallel, out through this focal point, because this is our primary focal point, in through the other focal point, stop when we get to the middle, go out parallel, and bring back those refracted rays, and they meet up all right there, and voila, that's where our image is. So you're going to practice this on your ray diagram for lenses worksheet. Good luck. We'll do that in class.